The roots of the equation x cubed plus 4x minus 1 equals 0 are alpha, beta, and gamma. Use the substitution y equals to 1 over 1 plus x to show that the equation 6y cubed minus 7y squared plus 3y minus 1 equals 0 has roots 1 over alpha plus 1, 1 over beta plus 1, and 1 over gamma plus 1. For the cases n equals 1, 2, and 3, find the values of 1 over alpha plus 1 raised to the power n, plus 1 over beta plus 1 raised to the power n, plus 1 over gamma plus 1 raised to the power n. Hence, show that beta plus 1 multiplied by gamma plus 1 over alpha plus 1 squared plus gamma plus 1 times alpha plus 1 over beta plus 1 squared plus alpha plus 1 plus beta plus 1 over gamma plus 1 squared equals to 73 over 36. Equals to 73 over 36. Now let's work it out. The original equation is x cubed plus 4x minus 1 equals 0. Now, to find the equation with these roots, you have to say y equals to 1 over 1 plus x. Now let's make x the subject. So we can say 1 over y equals to 1 plus x. So 1 over y minus 1 equals to x. Therefore I can say 1 minus y over y equals to x. Now let me substitute 1 minus y over y for x in this equation. So I can now say 1 minus y over y cubed plus 4 into 1 minus y over y minus 1 equals 0. Then, let me now multiply through by, 1 minus y cubed, then multiply through by y cubed plus 4y squared into 1 minus y cubed is equal to 0. So I can now say 1 minus y all cubed plus 4y squared minus 4y cubed minus y cubed is equal to 0. It's 4y squared. So 1 minus y cubed plus 4y squared minus 5y cubed is equal to 0. Now let me expand this one. I'm going to have 1 minus 3y plus 3y squared minus y cubed plus 4y squared minus 5y cubed is equal to 0. Now I can now say 1 minus 3y plus 6y squared plus 7y squared minus 6y cubed is equal to 0. Now let me multiply through by minus 1. So I'm going to have 6y cubed minus 7y squared plus 3y minus 1 equals 0. So let's see. That one is already proven. So that is done. The next one is now saying that we should find the cases of the sum of the roots. That is for this equation, s1y, s2y, and s3y. That's what this means. Because this one is, when n is 2, it will be squares of the roots. When n is 3, it is squares of the, is cube of the roots. Now let's see. What is s1y? And that is going to be minus 7 over 6, which is 7 over 6. I can also refer to this as summation alpha. sy, I can refer to this as summation alpha y squared, which should be summation alpha y all squared minus 2 summation alpha beta y. And what does that give me? What is summation alpha? That is 7 over 6 all squared minus 2 times alpha beta y, that is 3 over 6. And that is 49 over 36 minus 1. And that is 13 over 36. Now, I can go back into the equation to find S3, or I can use the formula direct. Let me see. Let me use the formula direct. So, S3y is equal to summation alpha cube minus 3 summation alpha beta plus 3 summation alpha beta gamma. I have gotten this. This one we got it from the equation, and this one is equal to minus this one over this. So let's go on. So this one is 7 over 6 cube minus 3 into 7 over 6. What is summation alpha beta? I got that one to be 3 over 6 plus 3. So that is minus 1 over 6. So that is 1 over 6. So this one is going to be 7 cube over 6 cube minus 3 times 7 times 3 over 6 squared plus 3 over 6. Now let me work it out. So this is giving me 73 over 6 cube over 2 and 6. So that's the answer for that. So when n equals to 1, the answer is 7 over 6. When n equals to 2, the answer is 13 over 36. When n is equal to 3, the answer is 73 over 216. Now let's go to the next part. So this part is asking us to show that this one sum up to this. Now let's work it out. Beta plus 1 into gamma plus 1 over alpha plus 1 all squared plus gamma plus 1 into alpha plus 1 over beta plus 1 all squared plus alpha plus 1 into beta plus 1 over alpha plus 1 over gamma plus 1 all cubed all squared. Now to rationalize this, I will have to multiply the numerator and denominator with the root of the square root of the denominator again. Let me show you what I'm talking about. So I multiply this place, the numerator and denominator again by alpha plus 1 to make sense. So it's going to be beta plus 1 into gamma plus 1 into alpha plus 1 over alpha plus 1 cube. So you see, I can extract this one conveniently. Plus gamma plus 1 into alpha plus 1 into beta plus 1 over beta plus 1 all cube plus alpha plus 1 into beta plus 1 into gamma plus 1 over gamma plus 1 all cube. So when I factorize this, you can see that they have common terms now. So it's going to be alpha plus 1 into beta plus 1 into gamma plus 1 into 1 over alpha plus 1 plus 1 over beta plus 1 cube plus 1 over gamma plus 1 cube. You can see. So this one is going to be 1 over the products of this one now. So which will be 1 over alpha plus 1 beta plus 1 gamma plus 1. That's the product into 1 over alpha plus 1 cube plus 1 over beta plus 1 cube plus 1 over gamma plus 1 cube. So please, I hope you are following. I don't have a quantity like this, but I can get a quantity like this. So it makes sense now. Now, this one, I have an answer for that one before. This one is S3y, and that is 73 over 2 and 6. This one, this other part, that is 1 over alpha plus 1 times 1 over beta plus 1 times 1 over gamma plus 1. That one is minus 1 over 6. Minus 1 over 6, which is 1 over 6. And this one is 1 over 6. This side is this place. Therefore, gamma plus 1 into beta plus 1 into gamma plus 1 will be equal to 6. Okay. I think it will be clearer. It will be clearer now. So this place, you don't need this place now. So this place and this place, I have gotten them out. Therefore, beta plus 1 into gamma plus 1 over alpha plus 1 squared plus alpha plus 1 into gamma plus 1 into alpha plus 1 over beta plus 1 squared plus alpha plus 1 into beta plus 1 over gamma plus 1 all squared is equal to this one is equal to alpha plus 1 into beta plus 1 into gamma plus 1 multiplied by this one let me make sure to x3y. This part is going to be 6 times 73 over 216. And that gives me 73 over 36. So it's already worked out now. So that's the solution. Very easy. I'm just trying to make it clearer in this case. So from here, we have gotten our answer. The rules of the quadratic equation x raised to the power 4 plus 4x cubed plus 2x squared minus 4x plus 1 equals 0 are alpha, beta, gamma, delta. Find the values of 1, alpha plus beta plus gamma plus delta. 2, alpha squared plus beta squared plus gamma squared plus delta squared. 3, 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. 4, alpha over beta gamma delta plus beta over alpha gamma delta plus gamma over alpha beta delta plus delta over alpha beta gamma. Using the substitution y equals x plus 1, find the quadratic equation in y. Solve this quadratic equation and hence find the roots of x raised to the power 4 plus 4x cubed plus 2x squared minus 4x plus 1. Now let's solve this. The equation we have is x raised to the power 4 plus 4x cubed plus 2x squared minus 4x plus 1 equals 0. So we want to get these ones. Number 1, summation alpha. We know that one to be minus 4 over 1. This is minus 4. You know, the coefficient of this divided by the coefficient of this. The next one is alpha, summation alpha squared, which is summation alpha all squared minus 2 summation alpha beta. And that will be minus 4 all squared minus 2 into 2 over 1. And that is 12. Please note, this one squared minus 2 times this one over this. This is positive. So I have 12 there. Now 3. It says summation 1 over alpha. And that is summation alpha beta gamma over summation alpha beta gamma delta. The numerator is this one. Is this one. Minus 4 over 1 divided by 1 over 1, and that is 4. That is 4. The last one, this one, is alpha over beta gamma delta plus beta over alpha gamma delta plus gamma over alpha beta delta plus delta over alpha beta gamma. So I want to solve this now. And when I look at it, the numerators and denominators are different. They don't have anything in common. So what do? Let me multiply the denominator and numerator again by the numerator. See what I'm saying? I multiply this one by alpha and this one again by alpha. Beta, beta, gamma, gamma, delta, delta. So I'm going to have alpha squared over alpha beta gamma delta plus beta squared over alpha beta gamma delta plus gamma squared over alpha beta gamma delta plus delta squared over alpha beta gamma delta. And what does this give us? It's going to be alpha squared plus beta squared plus gamma squared plus delta squared divided by alpha beta gamma delta. This one I got it here, and that is 12. This one is 1 over 1, and that is 1. So the answer here is 12. You can see the answer there is 12. Now y equals x plus 1. Therefore x equals y minus 1. So let's substitute this into this equation. So we are going to have y minus 1 raised to the power 4 plus 4 into y minus 1 cubed plus 2 into y minus 1 squared minus 4 into y minus 1 plus 1 equals 0. So for ease, let me arrange this vertically. So I make it like this: y minus 1 raised to the power 4 plus 4 into y minus 1 cubed plus 2 into y minus 1 squared minus 4 into y minus 1 plus 1 for ease. For ease, please. Now, this one, you know, from our binomial expansion, this one is going to be y raised to the power 4, and the next one is plus 4 y cubed times minus 1. So that will be minus 4 y cubed. Yes. Minus 4 y cubed And the next one will be 41, 42 plus 6 y squared. And the next one will be minus 4y. The next one will be plus 1. 1, 2, 3, 4, 5. Okay. This one is now going to be y raised to power 3 minus 3 y squared plus 3y minus 1. But don't forget, you have 4 here. So let's multiply this one by 4. And this one gives me 12. And this one gives me 12. And this one gives me 4. Please, bear with me. Just for ease, that's why I'm doing like that. So this one again, I have y squared minus 2y plus 1. But don't forget I have 2 here. So let me put 2 here. This one changes to 4. And this one changes to 2. Here I have minus 4y plus 4. And here I have 1. So let me add everything up. This one cancels this. So this is the sum. So this one, so this is giving me 4. Minus 4, minus 4, minus 4. So this one, 0y. So 6, 2, minus 4y squared. This one cancels. And this one, y raised to power 4. So at the end of the day, the answer for this one is going to be y raised to power 4 minus 4y squared plus 4 equals 0. So that is the answer. That's the new quartic equation formed, where y equals to x plus 1. That's the new quartic equation. And we are asked that we should find the root of this equation by finding the root of this one. You know the relationship between the root of this one and this one. The root of this one is greater than the root of this one by 1. Now let's solve this one. So let's make y squared equals to z. So z raised to power 2 minus 4z plus 4 equals 0. So from this, you can see that it's going to give us z squared minus 2z plus 4 equals 0. So I have z into z minus 2 into z minus 2. So I have z minus 2 all squared. So so z, since y squared equals to z, so I can now see that y and z here is equal to 2 twice. Z is equal to 2 twice. And you can see that. So it means that y is equal to plus or minus root of 2. That is y. Plus or minus root of 2. In all instances. So which means that the roots are repeated twice each time. So for x now, x will be equal to y minus 1. This root 2 is repeated. So all true. So x is now equal to plus root 2 minus 1 or minus root 2 minus 1. So this happens twice for this equation. So that one is solved now. The cubic equation x cubed minus x squared minus 3x minus 10 equals 0 has roots alpha, beta, gamma. Let u be equals to minus alpha plus beta plus gamma. Show that u plus 2 alpha equals 1. And hence, find a cubic equation having roots minus alpha plus beta plus gamma, comma, alpha minus beta plus gamma, comma, alpha plus beta minus gamma. 2. State the value of alpha, beta, gamma. And hence, find a cubic equation having roots 1 over beta, gamma, 1 over gamma alpha, 1 over alpha, beta. Now let's start. The original equation is x cubed minus x squared minus 3x minus 10 equals 0. And we are told that the roots are alpha, beta, gamma. U is equal to minus alpha plus beta plus gamma. Now, if we add 2 alpha to u, so u plus 2 alpha will be equal to minus alpha plus 2 alpha plus beta plus gamma, which should be alpha plus beta plus gamma. And now from the equation, we can see that summation of the roots, alpha plus beta plus gamma is equal to minus 1 over 1, which is 1. So we are proving that u plus 2 alpha is equal to 1. That one is proven. Now we are now asked to find a cubic equation having roots alpha minus beta. So the next one now is to find the roots, to find the new equation. We have said that u plus 2 alpha is equal to 1. So u equals to 1 minus 2 alpha. So in the same vein, you can now say y equals to 1 minus 2x. Simple. If you just translate this one to this one, y equals to 1 minus 2x. Therefore, x is equal to 1 minus y over 2. So that's our x. We will now substitute this back into the equation. So we have 1 minus y over 2 cubed minus 1 minus y over 2 squared minus 3 into 1 minus y over 2 minus 10 equals 0. Now let's multiply 2 by 8 for ease. So we can now say 1 minus y cubed. This is 4. So 2 into 1 minus y squared minus 3 times 4. That's 12 into 1 minus y minus 8 equals 0. Now let me arrange it and bring out the equation. 1 minus y cubed minus 2 into 1 minus y squared minus 12 into 1 minus y and minus 8 minus 8. So let's take it one by one. So this 1 minus 3. Now to form a cubic equation with roots minus alpha plus beta plus, so I can just say y plus 2x is equal to 1. So this is the second part. So y plus 2x is equal to 1. So y 1 minus y is equal to 2x. So x equals to 1 minus y over 2. So I have to substitute this into this equation now. So I'm going to have 1 minus y over 2 all cubed minus 1 minus y over 2 all squared minus 3 into 1 minus y over 2 minus 10 equals 0. You have that. Now, let's multiply 2 by 8, because this one is going to give us 8. This is 4, this is 2. Now, let's multiply 2 by 8. I'm going to have 1 minus y cubed minus 2 into 1 minus y squared minus 3 times 4 into 1 minus y minus 8 equals 0. Minus 8 equals 0. Then, let me arrange it. I am going to have 1 minus y cubed minus 2 into 1 minus y squared minus 12 into 1 minus y minus 80. So for ease, that's why I'm doing this summation. So let me expand it. So this one is going to give me 1 minus 3y plus 3y squared minus y cubed. For this one, if I expand what is in the bracket, I'm going to have 1 minus 2y plus y squared. Plus I have minus 2 here, so let me multiply 2 by minus 2. So I have minus 2 plus 4y minus 2y squared. This one, I have minus 12 plus 12y. And this one I have minus 80. Now let me add everything up. So for this minus 80, so this is minus 93. For the terms in y, that's minus plus 13y, y squared minus y cubed. So let's multiply 2 by, and everything here is equal to 0. Yes, this one, everything here is equal to 0. So let's multiply 2 by minus 1. I'm going to have y cubed minus y squared minus 13y plus 93 equals 0. So that is the cubic equation with this roots. That's the cubic equation with the roots minus alpha plus beta plus gamma plus alpha minus beta plus gamma plus, and then alpha plus beta minus gamma. So that's the roots. That's the new equation. That's the new equation for the. Now, it now says take the value of alpha, beta, gamma, and then find the cubic equation having roots this. The value of alpha, beta, and gamma, we can get it from this first equation. Alpha, beta, gamma is equal to minus 10 over 1, and that is 10. So that is for 2. It's now asking us again that we should find the cubic equation having roots 1 over beta gamma, 1 over alpha gamma, and whatever. So we can see that 1 over beta gamma is equal to alpha over 10. Because, okay, let me see. 1 over beta gamma will be equal to alpha over alpha beta gamma, which is equal to alpha over 10. So that's what it is. So the new equation is going to be like this. Y will be equal to x over 10. But let's make it z, yes. So for new equation, we can have something like this, z equals to x over 10. That's the new equation. So we now make x the surface of the formula. So x will be equal to 10z. We now substitute this into this equation. So let's see what it will be. So I have 10z cubed minus 10z squared minus 3 into 10z minus 10 equals 0. So here this is 1000 z cubed minus 100 z squared minus 30z minus 10 equals 0. Let me divide it by 10. So I have 100 z cubed minus 10z squared minus 3z minus 1 equals 0. So that's the new equation for 1 over beta gamma, 1 over gamma alpha, 1 over alpha beta. So that is it. So you understand how I got this one. So, and then I substituted it into the equation. We have this equation 2x cubed minus 9x squared minus 27x plus 54 equals 0. And we have the roots as geometric progression. So we have it in this form: a over r, a and ar for ease. We know that the r is the common ratio. Therefore, from our knowledge, the sum of the roots will be minus 9 over 2, that is a over r plus a plus ar is equal to minus 9 over 2, which is 9 over 2. That one there. Now, for sum of pairs, a over r times a plus a over r times ar plus a times ar, that will be minus 27 over 2. Minus 27 over 2. These two can give us our answer already. Because this one and this one, by the time we divide the two, we are going to have, so this one is a into 1 over r plus 1 plus r, 9 over 2. This one is a squared into 1 over r plus 1 plus r, and 27 over 2. So, if I use this one to divide this one, let me call this one 1, let me call this one 2. So 2 divided by 1, that is going to be a is equal to minus 27 over 2 times 2 over 9. So a is minus 3. You can see that a is minus 3. Now let's see how we can find our r. We can find our r from this place, even from this place conveniently. So from here, minus 3 into 1 over r plus 1 plus r is equal to 9 over 2. Now let's see. I bring this one here, I multiply both sides by 2. So I have minus 6 into 1 over r plus 1 plus r equals 9. Equals 9. Then I multiply 2 by r. So I have minus 6 into 1 plus r squared is equal to 9r. So I can ask, okay, let me now see. This will not be back be minus 6r minus 6r squared is equal to 9r. Let me bring this one here now. That will give me minus 6r squared minus 15r minus 6 equals 0. So let me multiply 2 by minus. So I have 6r squared minus plus 15r plus 6 equals 0. For each, let me divide 2 by 3. We have 2r squared plus 5r plus 2 equals 0. Then two numbers whose product will be 4 and whose sum will be 5. That is 4 and 1. So I have 2r squared plus 4r plus r plus 2 equals 0. So what do I have here? I have 2r into r plus 2 plus 1 into r plus 2 equals 0. So r equals, okay, let me do it. 2r plus 1 into r plus 2 equals 0. So r equals minus 1 over 2 or minus 2. So I have gotten the r and I have gotten the a. So the roots now I can easily get that a is minus 3 and r is equal to minus r or minus 2. Now when r equals to minus r, the roots will be minus 3 over minus half, minus 3 and minus 3 times minus half. So what does that give? This one gives 6 minus 3 and 3 over 2. And another one is when r equals to minus 2, the roots are minus 3 over minus 2, minus 3 and minus 3 times minus 2. So you can see we have 3 over 2, minus 3 and 6. So you can see the order is just changed. They are the same thing. 6 minus 3, 3 over 2. 3 over 2 minus 3 and 6. So that's the solution for that one. The root of the cubic equation 9x cubed minus 18x. The root of the cubic equation 9z cubed minus 18z squared minus 4z plus 8 equals 0 are in AP, arithmetic progression. A minus b, a plus d. Solve the equation. Now the equation we have is 9z cubed minus 18z squared minus 4z plus 8 equals 0. And the roots are a minus d, a and a plus d. So from our knowledge of sum and sum of pairs, whatever, let's look at how we can handle this. So we have a minus d plus a plus a plus d gives us minus 18 over 9. That is 2. And this one, what does it give us? A plus a, that's 3a. Minus d plus d, that's 0. So 3a is equal to 2. A equals to 2 over 3. A equals 2 over 3. Now we also have in pairs, that is a minus d into a plus a minus d into a plus d and a into a plus d is equal to minus 4 over 9. Minus 4 over 9. And the outside products of the three will give us this. Let's see how that one comes. Maybe that will be easier. So we have a minus a into a minus d into a plus d is equal to minus 8 over 9. And we have gotten our a. Let's see how it will help us here. So a into a squared minus d squared is equal to minus 8 over 9. And we know what our a is, 2 over 3. So we can say 2 over 3 into a squared minus d squared is equal to minus 8 over 9. So a squared minus d squared is equal to minus 8 over 9 times 3 over 2. So this one is 3. This one is 4. That is minus 4 over 3. Again, you know what our a is, 2 over 3. So we can now say 2 over 3 squared minus d squared is equal to minus 4 over 3. Minus over 3. So that is 4 over 9 minus d squared is equal to minus 4 over 3. Now, let me move this one here. So I have 4 over 9 plus 4 over 3 is equal to d squared. And so the LCM here is 9, and I have 4 plus 12 is equal to d squared. You can see. So 16 over 9 is equal to d squared. Therefore, d is equal to plus or minus 4 over 3. So you can see d equals to plus or minus 4 over 3. Now let's solve for the roots. If d is plus 4 over 3, it means that the roots will be 2 over 3 minus 4 over 3, 2 over 3, and 2 over 3 plus 4 over 3. So what do we have here? This one is minus 2 over 3, 2 over 3, and 6 over 3, that is 2. So if d is minus 4 over 3, what do I have? I have 2 over 3 minus 4 over 3, that is plus 4 over 3, 2 over 3, and 2 over 3 minus 4 over 3. So you can see this one is 2, 2 over 3, and minus 2 over 3. So you can see, just change the order. That's all. Minus 2 over 3, 2 over 3, 2, 2 over 3, minus 2 over 3. We are told that the root of the equation 2z cubed minus 12z squared plus kz minus 15 equals 0 are in AP. Solve and find k. So we can say that the roots, okay, the equation is 2z cubed minus 12z squared plus kz minus 15 equals 0. And the roots are in AP. So you can say the roots are a minus d, a plus d. Then the sum a minus d plus a plus d will be minus 12 over 2, and that is 6. So I can now say 3a equals 6. Therefore, a equals 2. So minus d plus d 0. I have gotten that one now. Now let me multiply all the roots, and that's going to be a into a minus d into a plus d will be minus 15 over 2 negative. So then I have gotten my a. So I can now say a into a squared minus d squared is equal to 15 over 2. And what is a? A is 2. Therefore, a squared minus d squared is equal to 15 over 4. And this is a. Therefore, d squared is equal to a squared minus 15 over 4. And what is a squared? That is 2 squared. So 4 minus 15 over 4, which is 1 over 4. You can see 16. Therefore, d is equal to plus or minus half. You can see d is equal to plus or minus half. So the root now can be, if d is taken as half, roots will be 2 minus half, 2 and 2 plus half. So what does that give me? 3 over 2, 2, 5 over 2. So when d is minus half, I'm going to have 2 plus half, 2 and 2 minus half. So it's going to be 5 over 2, 2 and 3 over 2. Then we also asked that we should find the value of k. And we know k to be the sum of the pairs of the roots. That is k over 2. K over 2 is summation alpha beta. That is sum of pairs of the roots. So let's see what our k will be. K over 2 will be equal to 5 over 2 times 2 plus 5 over 2 times 3 over 2 plus 2 times 3 over 2. You can see. So in either case, it will be the same thing. This is going to be 5 plus 15 over 4 plus 3. 5 plus 15 over 4 plus 3. And I can also express this one as 3 quarter. So it will be 5 plus 3 over 4 plus 3, which is 11 3 over 4. Therefore, k, okay, let me make it like this. This one is equal to 47 over 4. 47 over 4. Therefore, k over 2. K is equal to 47 over 4 times 2, which is 47 over 2. That is k. K is 47 over 2. Solve 32z cubed minus 14z plus 3 equals 0. Given that one root is twice one of the other. Solve 32z cubed minus 14z plus 3 equals 0. Given that one of the root is twice one of the other. Now let's arrange it like this. We have 32z cubed minus 14z plus 3 equals 0. And we have the roots as alpha, beta, and gamma. Now, I can say that alpha equals to 2 gamma. So I can now say alpha, beta, and alpha over 2, or alpha, or 2 gamma plus beta, 2 gamma, beta, and gamma. So I rather, this one makes it easy for me. Depends, you can take it like this, you can take it like this, anyone. Now, that is, I'm assuming that gamma is half of alpha. From this, we can see that there is no term in z squared. Therefore, the sum alpha 2 gamma plus beta plus gamma is equal to 0. We can see that 3 gamma plus beta is equal to 0. Therefore, beta is minus 3 gamma. That one is sure. We also have another thing here. The product, that is 2 gamma times beta times gamma again, is equal to minus 3 over 32. Therefore, you can see that 2 gamma squared times beta is equal to minus 3 over 32. But we also know that beta is minus 3 of gamma. So let's impute it here. So we can see 2 gamma squared times minus 3 gamma is equal to minus 3 over 32. And I can now say minus 6 gamma cubed is equal to minus 3 over 32. Now let's divide both sides by minus 6. Divide both sides by minus 6. So I have gamma cubed is equal to minus 3 over minus 6 times 32. So what does that give me? 1 over 64. That's 1 over 64. So gamma will be equal to 1 over 4. That is cube root of this. So if gamma is 1 over 4, alpha is equal to 2 times 1 over 4, and that is half. And beta is minus 3. Beta is minus 3 times gamma, which is minus 3 over 4. So that is a solution. So the roots are 1 over 4, minus 3 over 4, and sorry. The roots are half, minus 3 over 4, and 1 over 4. So that's the roots. The roots of z cubed plus pz squared plus qz plus r equals 0 are alpha minus alpha beta, and r is not equal to 0. Show that r equals pq and find all the roots in terms of p and q. So the equation is this: z cubed plus pz squared plus qz plus r equals 0. And the coefficient of z cubed is 1. Therefore, if the roots are alpha minus alpha and beta, we can now work some things out here now. Sum of the roots is equal to minus p. Sum of pairs of the roots is equal to q. And product of all the roots is equal to minus r. But this one here is equal to alpha minus alpha plus beta. That is beta alone. So minus p is equal to beta. And this one over this, okay, this one here is what? Alpha times minus alpha plus alpha times beta. Alpha times minus alpha plus alpha times beta plus minus alpha times beta. You can see. So this one you cancel this. So this one is giving me minus alpha squared. So minus alpha squared is equal to q. Minus alpha squared is equal to q. Now the product of everything, that is alpha into minus alpha into beta is equal to minus alpha squared beta. And if you look at it, minus r over minus p times q is equal to, what is this? Alpha squared beta over minus alpha squared times beta is equal to 1. So therefore, r equals to pq. R equals to pq. You can, just by observation, it's already shown. R equals to pq. Because the product of this one is this. That's all. Now, we have to find the roots in terms of p and q. We have seen that one of them is minus beta. That is r. Beta is minus q. And the product here is okay, q. I can easily find it from q there. So q equals to minus alpha squared. Therefore, alpha squared is equal to minus q. Alpha is equal to positive or negative minus q. So q, it's not necessary that this will give us complex roots or imaginary roots, because q can be, this q can be negative itself. So minus, so it can give us real or rational or irrational number, whatever. But it's not necessary to be imaginary or complex. And then you can also look at it from this by saying r over p. R over p is equal to minus alpha. So it can also be like that. Or saying minus r over p over minus p is equal to minus alpha squared over minus alpha squared beta over beta. So this one cancels this. So r over p is equal to minus alpha squared. So alpha squared is equal to minus r over p. So alpha is equal to plus or minus root of minus r over p. So that's it. Even from this expression here, it's the same thing. So that is our value for the roots. So we have so our root can be plus minus q, root of minus q, minus root of minus q and p and minus p. So or it can be the root can also be plus root of minus r over p minus root of minus r over p and minus p. So it can be, you can express it like this or like this. The equation z plus 2z squared plus 2pz plus q equals 0 has roots alpha, 2 alpha, and 4 alpha. Find all possible values of p, q, and alpha. Now we have it. The equation z plus pz squared plus 2pz plus q equals 0 has roots alpha, 2 alpha, and 4 alpha. Find all possible values of p, q, and alpha. We have this equation z plus pz squared plus 2pz plus q equals 0. And the roots are alpha, 2 alpha, 4 alpha. So the sum of the roots, alpha plus 2 alpha plus 4 alpha is equal to minus p. Since the coefficient of z squared is 1. Therefore, we have 7 alpha is equal to minus p. We can also take it in pairs. That is alpha into 2 alpha plus alpha into 4 alpha plus 2 alpha into 4 alpha. That is equal to 2p. That's equal to 2p. Therefore, 2 alpha squared plus 4 alpha squared plus 8 alpha squared is equal to 2p. Therefore, this is 14. 14 alpha squared is equal to 2p. 14 alpha squared is equal to 2p. Let's call this one. Let's call this one 2. If I should divide 2 by 1, that is going to give me 14 alpha squared over 7 alpha is equal to 2p over minus p. So this is minus p. So this one, therefore, 2 alpha is equal to minus 2. Alpha will be equal to minus 1. So I got an alpha. So alpha is equal to minus 1. So p, I can get p now. P is equal to minus 7 alpha, which is minus 7 times minus 1. That is 7. P is 7. Now I want to find q. To find q is the product. Minus q is the product of all these ones. So 4 alpha times 2 alpha times alpha is equal to minus q. And that is 8 alpha q is equal to minus q. So 8 into minus 1 raised to the power 3 is equal to minus q. So minus 8 is equal to minus q. So q is equal to 8. So alpha is minus 1, p is equal to 7, q is equal to 8. So it's very easy and straightforward. The cubic equation 8x plus px squared plus qx plus r equals 0 has roots alpha, 1 over 2 alpha and beta. Express p, q, and r in terms of alpha and beta. Show that 2r squared plus pr plus 4q equals 16. That's part 2. The third part says, given that p equals 6 and q equals to minus 23, find the two possible values of r and solve the equation 8x cubed plus 6x squared minus 23x plus r equals 0. Our equation is 8x cubed plus px squared plus qx plus r equals 0. And our roots are alpha, 1 over 2 alpha, and beta. We are now to find p, q, and r in terms of alpha and beta. The sum alpha plus 1 over 2 alpha plus beta will be equal to minus p over 8. Therefore, p is equal to minus 8 into alpha plus 1 over 2 alpha plus beta. You can expand it, you can leave it like this. That is the value for p. For q, q over 8 will be equal to sum in pairs. Alpha times 1 over 2 alpha plus alpha beta plus 1 over 2 alpha beta, which should be half plus alpha beta plus beta over 2 alpha. So Q will be equal to 8 into half plus alpha beta plus beta over 2 alpha. Minus R over 8 will be equal to the product, that is alpha times 1 over 2 alpha times beta, and that is beta over 2. Therefore, R will be equal to minus 4. R is minus 4 beta. R is minus 4 beta. Now we are told that this expression, we should prove that is equal to 16. That is 2R squared minus 3R plus 4Q is equal to 16. And what is R 2R squared? That is 2 into minus 4 beta R squared. PR will be this one times this. Minus into minus 8 times minus 4 beta into alpha plus 1 over 2 alpha plus beta. That is, so 4Q will be equal to plus 4 into 8 to half plus alpha beta plus beta over 2 alpha. Now let's expand each. This one. So this one is giving me minus 32 beta squared. This one is sorry. This one is giving me 32 beta squared. Please take note, 32 beta squared. This one, minus times minus, positive. So plus 32 beta into alpha plus 1 over 2 alpha plus beta. And this one again, oh, sorry, this is minus 32. Now, minus 4b squared is equal to 16b squared times 2, that is 32b squared. 32 beta squared, sorry. This is 32 beta squared. Minus times minus plus 8 times 8 is 32, so I have minus 32 beta into alpha plus 1 over 2 alpha plus beta. And this one again is 32 plus 32 into half plus alpha beta plus beta over 2 alpha. You can see that now. So let me multiply this one through by beta. So I have 32 beta squared minus 32 alpha beta minus 16 beta over alpha minus 32 beta squared. This one plus 16 plus 32 alpha beta plus 30 plus 16. This one times this one, 16 beta over alpha. Let's see what that gives us. Let's look at the like terms. This is 32 beta squared, and this one cancels this. This one is minus 32 alpha beta, and this one is 32 alpha beta. This one cancels this. This one is 16 beta over alpha, and this one is minus 16 beta over alpha. This one cancels this. At the end of the day, I am left with 16. So I approve this. 2r squared minus 2pr, 2r squared minus pr plus 4q is equal to 16. So that's done. We are now asked, given that p equals to 6, q equals to minus 23, find the two possible values of r and solve this equation. Let's find r. When p is given as 6, and then q is minus 23. Therefore, we can find r by saying 2r squared minus 6r, minus 6r minus 4 times 23, that's 92, minus 92 will be equal to 16. Therefore, I can now say 2r squared minus 6r minus 108 equals 0. Let me divide 2 by 2. So I have r squared minus 3r minus 54 equals 0. So I can now say r squared minus 9r plus 6r minus 54 equals 0. So r into r minus 9 plus 6 into r minus 9 equals 0. Therefore, r plus 6 into r minus 9 equals 0. So r equals to minus 6 or 9. Now we are asked to solve this equation here. That is 8x cubed plus 6x squared minus 23x plus r equals 0. If you compare it with this, you can see that p has become this. Q is minus 23 and r here. So that's what you have to do. And we have been given the condition before that. These are the situations. That is alpha, 1 over 2 alpha, and beta. Those are the situations we have now. Therefore, we can now see 8x cubed plus 6x squared minus 23x plus 9 equals 0. Say that r equals to minus 4 beta. Remember, so in this situation, it means that one of the roots we can easily get, that is 9 equals to minus 4 beta. So beta is equal to minus 9 over 4. We have been able to get beta now. Okay. Let me use the sum. That is alpha plus 1 over 2 alpha plus beta is equal to minus 6 over 8. And we know what our beta is, minus 9 over 4. So alpha plus 1 over 2 alpha is equal to minus 6 over 8 plus 9 over 4. This one comes in. And that is minus 6 plus 18 over 8, which is 12 over 8. So I can say, multiplying 2 by 2 alpha. 2 alpha squared plus 1 is equal to 12 times 2 alpha over 8, which is 3 alpha. Therefore, I can say 2 alpha minus 3 alpha, 2 alpha squared minus 3 alpha plus 1 equals 0. So 2 alpha squared minus 2 alpha minus alpha plus 1 equals 0. So you can see it has come to quadratic equation here. So I can now say 2 alpha into alpha minus 1 minus 1 into alpha minus 1 equals 0. So I have 2 alpha minus 1 and alpha minus 1 equals 0. Therefore, alpha is equal to half or 1. So either way, alpha is equal to 1 or alpha. Therefore, when r equals to 9, the roots are 1, half, and minus 9 over 4. Minus 9 over 4. Now let's look at it when r is equal to minus 6. Now when r equals to minus 6, you can say that beta is equal to, we got that beta is minus r over 4. So it is going to be minus 6 over 4, which is 3 over 2. That one has, we have solved that one there. Then let's now solve the other ones as we did previously. Our equation is still 8x cubed plus 6x squared minus 23x minus 6 equals 0. So from here, our beta is minus r over 4, which is minus 6 over 4. That's 3 over 2. Now, the sum of the roots is minus 6 over 8. So we have alpha plus 1 over 2 alpha plus beta is equal to minus 6 over 8. And our beta, we are gotten to be 2 over 3. So alpha plus 1 over 2 alpha is equal to minus 6 over 8 minus 3 over 2. And this is minus 6 minus 12 over 2. This gives over 8, sorry. And this gives minus 18 over 8. This is minus 9 over 4. Therefore, alpha plus 1 over 2 alpha is equal to minus 9 over 4. Let's multiply 2 by 2 alpha. So I have 2 alpha squared plus 1 is equal to minus 9 times 2 alpha over 4. That is minus 9 over 2 alpha. For ease, let's multiply 2 by 2 again. So that's going to be 4 alpha squared plus 2 is equal to minus 9 alpha. Therefore, 4 alpha squared plus 9 alpha plus 2 equals 0. Therefore, 4 alpha squared plus 9 plus 8 alpha plus alpha plus 2 equals 0. Because 8 times 1 is equal to 8. That is 4 times 2. 8 plus 1 is equal to 9. That's how I got it. So I can now factorize easily. 4 alpha into alpha plus 2 plus 1 into alpha plus 2. equals 0. So 4 alpha plus 1 into alpha plus 2 equals 0. So alpha is equal to minus 1 over 4 or minus 2. Therefore, the roots when r equals minus 6 are minus 2, minus 1 over 4, and 3 over 2. So we have done everything now. We've done it. We initially got r, and from that we are able to get what are the possible roots of the equation. Show that one root of az cubed plus bdz squared plus cz plus d equals 0 is the reciprocal of another root if and only if a squared minus d squared is equal to ac minus bd. Verify that this condition is satisfied for the equation 21z cubed minus 16z squared minus 95z plus 42 equals 0, and hence solve the equation. We have this az cubed plus bz squared plus cz plus d equals 0. And we also have our roots like this: alpha, 1 over alpha, and beta. We are now asked to show that if this situation arises, a squared minus d squared will be equal to ac minus bd. Now let's look at it. The sum, that is alpha plus 1 over alpha plus beta, is equal to minus b over a. The sum in pairs, that is alpha into 1 over alpha plus alpha into beta plus 1 over alpha into beta is equal to c over a. Now let me work this out. So I have 1 plus alpha beta plus beta over alpha is equal to c over a. Is equal to c over a. Now the product, that is alpha, the product alpha times 1 over alpha times beta is equal to minus d over a. So this one cancels. So beta, one of the roots is minus d over a. One of the roots is minus d over a. And now I can substitute it here. I can substitute it here. Let's see what will happen here. Therefore, alpha plus 1 over alpha minus d over a is equal to minus b over a. At the same time, I can also say in this place, this one is also equal to 1 plus beta into alpha plus 1 over alpha. So I can now say 1 plus beta into alpha plus 1 over alpha is equal to c over a. Now, I'm trying to establish something here. Alpha plus 1 over alpha is d over a minus b over a. Alpha plus 1 over alpha is equal to d over a minus b over a. You can see that. And here now, I can also say that 1 plus minus d over a into d over a minus b over a is equal to c over a. Please, I hope you are following. This one is there, this one is here. Now, I can now say 1 minus d squared over a squared plus bd over a squared is equal to c over a. You can see that now. Now, let's do something again. Let's multiply through by a squared. So I have a squared minus d squared plus bd is equal to ac. Now let's subtract bd from both sides. I have a squared minus d squared is equal to ac minus bd. So we have established this now. So please, I hope you are following. It's very straightforward. Just take care in every substitution you are making. That's all. Now we are asked to find that this condition is applicable here. Now what is our a? Let's write out the equation. 21 z cubed minus 16 z squared minus 95 z plus 42 equals 0. So we want to verify if this condition is in this equation. Our a is 21. So we can now see 21 squared minus, what is our d? 42. 42 squared is equal to, what is our a again? 21. What is our c? Minus 95. What is our b? Minus 16. What is our d? 42. This one is 21 squared into 1 minus 2 squared is equal to, look at this, 21 into minus 95 plus 2 times 16. So this is 21 squared times minus 3 is equal to 21 times minus 63. So by the time you look at this one is also equal to 21 times 21 times minus 3. So 21 squared times minus 3 is also equal to 21 times minus 63. So it is applicable here. So since we have verified that it is applicable, we can now go on and solve our equation. Now for the equation, 21z cubed minus 16z squared minus 95z plus 42 equals 0. We have been able to verify that a squared minus b squared is equal to ac minus bd. And what does that tell us? It means that one of the roots is reciprocal of the other one. That is, we have the root in this sequence and beta. So the product of the roots, that is alpha times 1 over alpha times beta, is equal to minus 42 over 21. So one of the roots is equal to minus 2. So we have gotten one of the roots to be minus 2. Let's look at the sum of the roots. Alpha plus 1 over alpha plus beta is equal to minus 16 over 21, which is 16 over 21. And you have noticed that our beta is minus 2. So alpha plus 1 over alpha minus 2 is equal to 16 over 21. Therefore, alpha plus 1 over alpha is equal to 16 over 21 plus 2, which is 16 plus 42 over 21. That is 58 over 21. Now let's multiply through by alpha. So I have alpha squared plus 1 is equal to 58 alpha over 21. Multiplying through by 21, let's do that. 21 alpha squared plus 21 is equal to 58 alpha. Now let's bring everything together. We have 21 alpha squared minus 58 alpha plus 21 equals 0. So I have 21 alpha squared minus 49 alpha minus 9 alpha plus 21 equals 0. Now let's factorize this. I have 7 goes in both. So 7 alpha into 3 alpha minus 7, and here 3 minus 3 into 3 alpha minus 7 equals 0. So I have 7 alpha minus 3 into 3 alpha minus 7 equals 0. So alpha equals 3 over 7 or 7 over 3. So the roots of this equation, 21z cubed minus 16z squared minus 95z plus 42 are roots of 21z cubed minus 16z squared minus 95z plus 42 equals 0 are minus 2, 3 over 7 and 7 over 3. So that's the solution. Find the formula connecting a, b, c, and d, which is a necessary and sufficient condition for the roots of the equation az cubed bz squared plus cz plus d equals 0 to be in geometric progression. Show that the condition is satisfied for the equation az cubed minus 56z squared plus 78z minus 27 equals 0, and hence solve the equation. So we are asked to find relationship between a, b, c, and d in this equation. Az cubed plus bz squared plus cz plus d equals 0. When the roots are in geometric progression, that is, the roots are alpha over r, alpha, and alpha r. Now, for this to be the condition, we are going to have it like this. Alpha over r plus alpha r is going to give us minus b over a. Sum in pairs. Alpha over r times alpha plus alpha over r times alpha r plus alpha times alpha r will be c over a. The product, alpha over r times alpha r is going to give us minus d over a. That gives us minus d over a. Now from this, let's take it one after the other. This one cancels this. What does that mean? It means that alpha cube is equal to minus d over a. That is alpha cube minus d over a. Now let's look at this one here. We have alpha into 1 over r plus 1 plus r equals minus b over a. And in this case too, let's work it out. You can see that alpha squared is common to all. So we have alpha squared into 1 over r plus 1 plus r equals c over a. Because let me divide 2 by 1. Divide equation 2 by equation 1. Therefore, I'm going to have it like this. Alpha squared into 1 over r plus 1 plus r over alpha is going to be c over a times minus a over b. This one cancels this. 1 over r plus 1 plus r. Sorry. So this one cancels this. So alpha is equal to minus c over b. And from here too, alpha cube is equal to minus d over a. So let me cube this one now. It shows that alpha cube is equal to minus c cube over b cube. So what does that imply? It means that minus c cube over b cube is equal to minus d over a. So let me cancel this. So which means that a c cube is equal to b cube d. A c cube is equal to b cube d. Now we have to see if this condition is here now. What is our a in this place? Let me write it out. A is z cube minus 52 z squared plus 78 z minus 27 equals 0. So in this case, a is 8, b is minus 52, c is 78, and d is 27. Now let's check. What is our? So we can say that 8 times 78 cube. Let's find what that is. And b, that is minus 52. Oh, sorry, d is minus 27, please. So minus 52 cube times minus 27. Let's see what this will give us. So from my calculation, my a c cube is 3,796,416, and my b cube d is the same, 3,796,416. So which means that the roots of this equation are also in geometric progression. That's what it means. So it is applicable in this situation. So this information will make it easy for us to find the roots of this equation. Let's see. So what do we have now? We have 8z cubed minus 52z squared plus 78z minus 27 equals 0. And the roots are alpha over r plus alpha r is going to give me minus 52 over 8. That's 52 over 8, sorry. And I can also get that the product of everything, that is alpha r times alpha r. Alpha over r times alpha r is equal to minus 27 over 8. So alpha cube is equal to 27 over 8. So alpha is 3 over 2. So I've gotten alpha there. 3 over 2. And from this place, I can also see that alpha into 1 over r plus 1 plus r is equal to 52 over 8. And my alpha is 3 over 2. I can now say 1 over r plus 1 plus r is equal to 52 over 8 times 2 over 3. So that I don't waste time. Here is 4. So I'm going to have 52 over 12. Let me subtract 1 from both sides. I'm going to have 1 over r plus r is equal to 52 minus 12 over 12. That is 40 over 12. Multiply 2 by r. Now, I have 1 plus r squared is equal to 40r over 12. Multiply 2 by 12. I have 12 plus 12 r squared is equal to 40. 12. I have 12 plus 12 r squared is equal to 40r. So I can now say 12 r squared minus 40r plus 12 equals 0. So I can now say 12r squared minus 36r minus 4r plus 12 equals 0. So 12r into r minus 3 minus 4 into r minus 3 equals 0. So 12r minus 4 into r minus 3 is equal to 0. So from here, let me even divide this one by 4 again. And I've done that. So 4 into 3r minus 1 into r minus 3 is equal to 0. So r equals 1 over 3 or 3. r equals to 1 over 3 or 3. So we have gotten alpha here. So if r is 1 over 3, we are going to have 3 over 2 times 3 over 1, 3 over 2, and 3 over 2 times 1 over 3. So it's going to be 9 over 2, 3 over 2, and half. But if r is equal to 3, we are going to have 3 over 2 times 3, 3 over 2, and 3 times 3 over 2. And that's going to be half, 3 over 2, and 9 over 2. So you can see. We have this x raised to the power 4. For the quadratic equation, x raised to the power 4 into a minus 2 x cubed plus x squared plus x plus a equals 0. Summation alpha equals summation alpha beta gamma delta. Find the value of a. So our equation is x raised to the power 4 plus a minus 2 into x cubed plus x squared plus x plus a equals 0. And this summation alpha is equal to minus into a minus 2. Summation alpha beta gamma delta will be equal to negative, positive, negative, positive a. And we have been informed in the equation that summation alpha is equal to summation alpha beta gamma delta. Therefore, minus into a minus 2 is equal to a. So we can say a minus a plus 2 is equal to a. So 2 equals to a plus a, which is equal to 2a. Therefore, a is equal to 2a over 2 is equal to 1. So we have been able to solve that now. The root of the quadratic equation 4z raised to the power 4 plus bz cubed plus qz squared minus z plus 3 equals 0 are alpha minus alpha, alpha plus lambda, and alpha minus lambda, where alpha and lambda are real numbers. 1. Express p and q in terms of alpha and lambda. 2. Show that alpha equals to minus half and find the values of p and q. 3. Give the roots of the equation. Now, the equation we have is 4z raised to the power 4 plus pz cubed plus qz squared minus z plus 3 equals 0. And the roots are alpha minus alpha, alpha plus lambda, alpha minus lambda. So we are now asked to find p and q in terms of alpha and lambda. Now let's see what we can do. The sum of the roots, that is sum of roots, that is alpha minus alpha plus lambda plus alpha minus lambda is equal to minus p over 4. That is the sum. Now this one cancels this one cancels this. Therefore, 2 alpha is equal to minus p over 4. So 8 alpha is equal to minus p. Therefore, p is equal to minus 8 alpha. That is for p. Now let's look for q. Q over 4 is the product, is the sum of the product in pairs. So how do I mean to be this one times this one, this one times this one, this one times this one? Then we take them until they form the pairs. So we have alpha into minus alpha, q over 4, plus alpha into alpha plus lambda, plus alpha into alpha minus lambda. Continue here, plus now minus alpha into alpha plus lambda, minus alpha into alpha minus lambda, plus alpha plus lambda into alpha minus lambda. So I have 1, 2, 3, 4, 5, 6. So it's complete. Now let's look at it. This one and this one cancels out. This one and this one cancels out. So I'm now having minus alpha squared plus alpha squared minus lambda squared. So this one now cancels this. Therefore, q over 4 equals to minus lambda squared. Therefore, q is equal to minus 4 lambda squared. So we have found our p to be equal to minus 8 alpha and our q to be minus 4 lambda squared. So that is for the first one. Now let's go to the second one. It's telling us to find the value of alpha and that it is half. Here, we know that the product of all the roots will be 3 over 4. That is alpha times minus alpha times alpha plus lambda times alpha minus lambda will be equal to 3 over 4. And the products, the sum of the product in trees is minus 1 over 4. So that is going to be alpha times minus alpha times alpha plus lambda plus alpha times alpha plus lambda times minus alpha, sorry, times alpha minus lambda. So that's another one. So this one. So I can also minus lambda into alpha plus lambda into alpha minus lambda. So I have plus lambda, alpha, yeah, into lambda plus alpha into lambda minus alpha. So I have this is equal to minus 1 over 4. It's 1 over 4. That's 1 over 4. And let me work it out. This one, alpha, and this one, we cancel out. Lambda. So here, I have minus alpha squared into alpha plus lambda minus alpha squared into alpha minus lambda is equal to 1 over 4. Now, I can now say minus alpha squared into lambda plus alpha plus lambda plus alpha minus lambda is equal to 1 over 4. And this gives me minus alpha squared into 2 alpha is equal to 1 over 4. Therefore, minus 2 alpha cube is equal to 1 over 4. So alpha cube is equal to 1 over 4 times minus half, which is minus 1 over 8. Therefore, lambda is equal to cube root 1 over minus 1 over 8, which is half. So we have established that our alpha is equal to minus half. We have established that our alpha is minus half. Now, alpha is equal to minus half. And I want to get lambda now. Let me use, so from here I can get what P is. P is equal to minus 8 alpha, which is minus 8 times minus half, which is 4. So P equals to 4 times alpha times alpha plus lambda into alpha minus lambda is equal to 3 over 4. And this one is minus 1 over 4 into 1 over 4 minus lambda squared plus 3 over 4. Then multiply both sides by minus 4. So I have 1 over 4 minus lambda squared is equal to 3 over 4 times minus 4. Minus 3. That's minus 3. So minus lambda squared is equal to minus 3 minus 1 over 4, which is minus 13 over 4. So lambda squared is equal to 13 over 4. Therefore, lambda is equal to plus or minus root of 13 over 4. Now, since the roots are alpha minus alpha, alpha plus lambda, and alpha minus lambda, so lambda can take either positive or negative. So these are the roots: minus half, half, minus half, plus root of 13 over 4, and minus half minus root of 13 over 4. So that is, those are the roots. So you have been able to do this one. You have been able to get these ones too. So Q, I got P, and Q will also be equal to minus 4 lambda squared, which is minus 4 times 13 over 4, and that will be minus 13. So Q is minus 13, P is 4, and the roots are minus half, half, minus half plus root 13 over 4, minus half minus root 13 over 4. The quartic equation x raised to the power 4 plus px cubed minus 12x plus q equals 0, where p and q are real, has roots alpha, 3 alpha, beta, and minus beta. By considering the coefficients of x squared and x, find alpha and beta when beta is greater than 0. 2. Show that p equals to 4 and find the value of q. 3. By making the substitution y equals x minus k for a suitable value of k, find a cubic equation in y with integer coefficients, which has roots minus 2 alpha, beta minus 3 alpha, minus beta minus 3 alpha. Here, the equation is x raised to the power 4 plus p x cubed minus 12x plus q equals 0. And the roots are alpha, 3 alpha, beta, and minus beta. So x squared is equal to 0, and it is equal to summation alpha beta, because the coefficient of x raised to the power 4 is 1. Coefficient of x is equal to minus 12, and it is equal to minus summation alpha, beta, and gamma. That is the sum of the roots in pairs, in threes. Therefore, summation alpha, beta, gamma is equal to 12. So let's use these two knowledge to find our alpha and beta. Now let's take it in pairs. That is alpha times 3 alpha plus alpha times beta plus alpha times minus beta plus 3 alpha times beta plus 3 alpha times minus beta plus beta times minus beta is equal to 0. So I have 1, 2, 3, 4, 5, and 6. So that's 0. Let me now bring it out. I have 3 alpha squared. This one will cancel this. This one cancels this. So I have 3 alpha squared minus beta squared is equal to 0. That one is clear. Now let me do this one. That is alpha times 3 alpha times beta plus alpha times 3 alpha times minus beta plus alpha times beta times minus beta is equal to 12. So if you look at this one and this one will cancel. So I have minus alpha beta squared is equal to 12. Now, let me see if I multiply this one by alpha. That's what it will give me. So I have 3 alpha cubed minus alpha beta squared is equal to 0. So if I should subtract this from this, I subtract this one from this one, it's going to give you minus 12. Huh? So for this one now, for this one, I have alpha times 3 alpha times beta plus alpha times 3 alpha times minus beta plus alpha times beta times minus beta plus 3 alpha times beta times minus beta is equal to 12. So let's work this one, we cancel out this. And this is alpha beta minus beta. 3 alpha beta minus beta. So I'm going to have minus 4 alpha beta squared. So minus 4 alpha beta squared is equal to 12. And from here, I have 3 alpha squared minus beta squared is equal to 0. So let me multiply this one through by alpha. So I have 3 alpha cubed minus, let me multiply this one by 4 alpha. So I have 12 alpha cubed minus 4 alpha beta squared is equal to 0. Now let me subtract this from this place. So therefore 12 alpha cubed is equal to minus 12. So alpha cubed is equal to minus 1. Alpha is equal to minus 1. Please try to get what I did here. I subtracted this one from this one. So this one will cancel. And then this one becomes minus 12. So that's how I got it. So we have gotten our alpha now. Alpha is equal to minus 1. Now let me now work for beta. So I can get my beta from this place. I can say 3 into minus 1 squared minus beta squared is equal to 0. So 3 minus beta squared is equal to 0. So beta squared is equal to 3. Therefore beta is equal to root. Beta is equal to root 3. Beta is equal to root 3. So the roots are minus 1, minus 3, root 3, and minus root 3, depending on which one you want to put for. So those are the roots. Now let's look at the second part. It says show that P equals 4 and find the value of Q. We have know that minus p is sum of the roots, and which is equal to minus 1 minus 3 plus root 3 minus root 3, which is equal to minus 4. Therefore, p is equal to 4. So we have established that p is equal to 4. We are now asked to find the value of q. The value of q. And how do we do that? It will be the product of all the roots. So q is minus 1 times minus 3 times root 3 times minus root 3. So what does that give us? This one is 3, this one is minus 3, and q is minus 9. So that's the value of q, minus 9. Now the last part says, by making the substitution y equals x minus k for a suitable value of k, find a cubic equation in y with integral coefficients, which has root minus 2 alpha, b minus 3 alpha, and minus b beta minus 3 alpha. Now we know our alpha to be equal to minus 1, and 3 alpha is equal to 3. And if you do that for the first one, alpha minus 3 alpha is going to give us minus 2 alpha. 3 alpha minus 3 alpha is going to be 0. So we can now see that the normal substitution should be y equals x minus 3 into minus 1. That's it. Yes. So which is x plus 3. X plus 3. That's what we will have there. And now we will now substitute x plus 3 into this equation to get the new equation. So let's do that. First, let us write out the equation as it should be. We are going to have x raised to the power 4. What's our p? 4 plus 4x minus 12x. Q is minus 9. Minus 9 equals 0. So now let us substitute x plus 3 into the equation. So I'm going to have y plus 3m. So since y equals to x plus 3, therefore x will be equal to y minus 3. So let me put y minus 3 into the equation. So y minus 3 raised to the power 4 plus 4. Oh, this one's cube. 4 into y minus 3 cube minus 12 into y minus 3 minus 9 equals 0. Equals 0. Now to make it easy, let's make it like this. Y minus 3 raised to the power 4. 4 into y minus 3 cube minus 12 into y minus 3 minus 9. Now let's expand each. Let's expand each. So this one is giving me y raised to the power 4. 4 times y cube times minus 3. That's minus 12 y cube. Then the next one will be, this is 462. That's 4 times 3 over 6. So the next one will be 6 y squared times minus 3 squared. That's going to be plus 54 y squared. The next one will now be 4 times 3 raised to power 3. 4 times minus 3 raised to power 3. That is minus 108 y. 108 y. And minus 3 raised to power 4 is 81 plus 81. Please, that is binomial expansion. Now, let me first of all expand y minus 3 cubed before I multiply by 4. So I'm going to have y cubed plus 3 y squared times minus 3. That is minus 9 y squared. And then plus 3 times y times minus 3 squared. That is plus 27 y minus 27. That is the expansion for this. Now, I multiply by 4. So I have 4 y cubed, 36 y squared, 108 y, and 108 here as well. Please, I want you to follow. Expanding. This one now is going to give minus 12y plus 36. And here I have minus 9. Now let me add everything together. Now let's find the total. The total is 0 from this place, so 0. Now, this one is y raised to the power 4 minus 12y cubed plus 4y cubed. That is minus 8y cubed. 54y squared minus 36y squared. That is 18y squared plus 18y squared. Now, minus 108 plus 108, that's 0. Minus 12y. So we have minus 12y. Here, 81 plus 36, that is 117. Minus 108 minus 9, that is minus 117. So this part sums to 0. So our equation now is y raised to the power 4 minus 8y cubed plus 18y squared minus 12y equals 0. So one of the roots is 0 from what you have done here. One of the roots is 0. That is this one. 3 alpha minus 3 alpha is 0. Therefore, if you divide through by y, divide through by y, we are going to have y cubed minus 8y squared plus 18y minus 12 equals 0. So this is the cubic equation we are asked to find, since one of the roots are made 0. So this is the answer. Please, if you have not subscribed, kindly subscribe, share, comment, and then like. Please let others know about it. That's the only way we can get encouraged. And if there is any question, you are free to ask, please. And anything that you think I can do, I wish to say thank you very much. I appreciate you all. Thank you very much.